Hi everybody. What an insane weekend, wasn't it? I mean, we had this last match day of Zweite Bundesliga and Holstein Kiel couldn't manage to do it directly with the Aufstieg. So yeah, we have to be very focused tonight. Today is Wednesday, yes, of course. So Wednesday evening, tonight, we have to be very focused on the first leg of the Relegationsspiel. So it's probably a good reason for doing a little slower this week. By the way, we had a public holiday on Monday, so if we wouldn't be in the online format, if we would be in presence, probably we would take it quite slow this week. So I think there are plenty of reasons to take it slow this week. So we are going to take it slow this week. What's coming up? Well, we are talking about clustering high-dimensional data this week, or we start with it because this is again a big subtopic. We will see that in clustering, at least in this subsection here, most of these methods are basically embedded methods in the sense of what we talked before. Let's see what we talked before here in the supervised section. Yeah, we talked about here this what were it here? These different methods, yeah, and we talked about embedded methods where we somehow integrate the feature selection part into the learning algorithm, and that's actually what is done here in the clustering part. Yeah, so there are a lot of clustering methods for high-dimensional data that integrate the feature selection part into the clustering, couple it, embed it. Maybe a good reason for that is since you don't know what's the outcome and you have to do this puzzle playing thing with exploratory data analysis in the unsupervised setting, introducing several pre-processing steps introduces some more degree of freedom where you can do wrong. Yeah, so instead of applying several different methods in a process from the raw data to the patterns, we try to apply just one which integrates all of those steps here. Yeah. Maybe that is some kind of reason why those methods are quite popular, and maybe you also see in this challenge subsection here some other reasons for that. Yeah? So most of or basically all of these methods that we get to know now in this subsection 5 are actually embedded methods, yeah, for clustering, so for the unsupervised setting. And this week we're talking about the challenges and about the first part or the first kind of those methods that are called subspace clustering algorithms. So we'll probably stop after subspace clustering this week because we have to be focused tonight. And of course on Sunday where everything is decided about the Aufstieg or not. But anyway, so just that you know here, we have different kinds of clustering methods, embedded high-dimensional clustering methods, feature selection clustering methods, whatever. And we try to give you a kind of taxonomy here by these terms here. So subspace clustering is a specific kind of methods that work in a specific way other than projected clustering algorithms, other than pattern-based clustering algorithms, and finally other than correlation clustering algorithms. So all these 4 different classes of methods have different properties and different general ideas how to actually tackle the problem of clustering in high-dimensional data. Well, why is that a problem? We already talked about a lot the problems of the curse of dimensionality, but we have to somehow revisit the whole stuff to set the scene, so to say, for all these methods. And let's see here. So we start with an example, hopefully a motivating example. So one of the motivating examples that we could use here is the baby shape game, actually, because that's what is now all about. But we have maybe some more relevant in practice, more relevant problem, which is customer recommendation or target marketing. So what is the data about here? Well, we have customer ratings for products. That means that the rows are the customers, maybe millions of customers, of course, and the columns are the products. Yeah? So the features are the products that are rated by the customers, and maybe we have hundreds to thousands of these products that are rated by customers. And of course, one value in the data matrix is the rating of a given product, for example, a movie or stuff like that, by a given user. Yeah? And that somehow reminds you probably on the data set that we had for the SVD example. And again, the task is somehow to cluster fine groups of customers, so of persons that share similar preferences or also disfavors, of course. Yeah? For example, then we can do personalized marketing, send all those persons in one cluster some offer that they cannot reject or whatever. Yeah. So that is the idea. We want to cluster the rows, of course, the customers, the persons, according to similar preferences and disfavors. And once again, that somehow reminds you probably about this data set we had for SVD, and SVD was quite good in that actually already. So SVD is a kind of embedded method somehow there, but the challenge now here is, and that should remind you on the baby shape game, that now customers may be grouped differently according to different preferences or different disfavors so according to different products actually. Yeah? So different subsets of products may have a different impact on how to cluster the customers, or a customer, in another word, a customer may be grouped in different clusters according to different subsets of products. Yeah? And that is the same as the baby shape game. So we had the baby shape game, we had these toys, and each toy could go in different clusters, one depending on the semantic level. Yeah? So one was a clustering according to the color, and one was a clustering according to shapes. The toys, the items, go into different clusters according to those different semantic levels, shape or color. Yeah? And that may be true here also, and that is actually the limitation of SVD. So if we do SVD and we get a clear rank, which is lower than the dimensionality, well, that's fine, but that is very, very unlikely in these situations where we have different semantic levels, or different semantic concepts in our features, represented in our features. And that is probably true also in customer recommendation, because we have a lot of products, maybe movies, and people have different favors, of course, and different disfavors. Depending on which subset of products of movies, for example, we look at, persons may share different favors and disfavors with different people. No? So that is the point, and in this scenario, SVD is cannot give you anything, because that will somehow group or associate columns with specific rows, and that's it. Yeah, but in a kind of one-to-one mapping. But now we have an N-to-N mapping somehow between the persons and clusters of persons and subsets of features. Yeah? So. And the problem again is relevance and irrelevance. Yeah? So again is, when is some feature really relevant to a cluster, and when it is irrelevant. Yeah? So not all features, of course, but just a subset of features may be relevant for a given clustering. Well, we already talked about that a lot. So here is another visualization of that. Yeah? So for this cluster of these points here, which is probably not a cluster in the two-dimensional space, but if we project all those points here on this subspace here, which is the relevant attribute, the relevant subspace, then we'll see that they are all extremely similar. So if we just look at this relevant subspace, this may be a clear cluster. Yeah? So groups of points, groups of similar points, groups of similar objects, dense objects or whatever, may be identified only when considering these relevant subspaces, these relevant attributes. Yeah? And once again, and this is what makes it a little bit more severe, is that different subsets of attributes may be relevant for different clusters. So there may be a different cluster, which maybe is something like some points following this line here, and then this attribute would be relevant for this second cluster. Yeah? And that makes it much harder than before, so to say.